So this is the fourth and the final lesson of this series. And in this lesson, we're going to add details to the scene because we want to get to use WebGL to add some cool stuff, not just a static scene. We could have done a video or just a render to get this result, even though we can already turn around the scene, which is cool. We're going to add more stuff in it, and we're going to use what we learned in the previous lessons. We're going to add fireflies, so it's just some kind of little fireflies floating around, and we are going obviously to change the what you see, the portal. Even though this bright material is looking good, we can do even better and create some kind of distortion, perling, stuff like that, a cool animation with shaders, obviously. All right, for the setup, it's exactly what we had in the previous lesson, so you can start from what you had. You can also obviously download the starter if you want the exact same thing as me, but you can totally use your file, your export, your code. It should be fine. Yeah, so we have that GUI that we are going to use now. We did load the model, we have the orbit control, we have the loader, stuff like that. So yeah, it's all good. Let's move forward. So first, before playing with the fireflies and the portal, we are going to change the background color because it's not really immersive to have this black background. We want something else. We're not going to do a lot of changes for the background, just something more in the mood of our scene. Obviously, you will be able to choose any background you'd like, but me, I would just go for something kind of a dark brown. So yeah, let's go. Nothing too hard here. But because we want to tweak this value, we need to add it to that GUI. And if you remember from the previous lessons, we need some kind of debug object just to be able to put the value, so the color, inside a property, inside an object. So let's go. First, we're going to create this object. So debug object equal like this. It's just to have an object and we'll be able to put stuff in it. And later, let me check. Yeah, later we can change in the for the renderer. So my renderer is over here. We can do it after those output encoding, set size, and set pixel ratio. We're going to create a property inside that debug object. It's going to be clear color, and we're going to start with just some kind of red like this, just to see if it's working before choosing any exact color. We can already add it to that GUI, so we use the add color method. It's on our debug object, and the name of the property is clear color, just like we choose it here. All right, we now have our debug tweak color here. We can change it. It seems to be working, but obviously it's not yet linked to our scene, our project. So what we can do here is use this color to change the background already. To do that, we can do renderer, and to change the background color, we use set clear color, which is why we choose to name it clear color. It's because it's the name used in Three.js. So debug object, clear color like this, and it should be red. Perfect, it's working. All right, cool. But if we change this one, it's not working because yes, we did use it, but when we change this one, it doesn't update this one automatically. This is how JavaScript works. It's a reference. It's not a reference, it's the value. So we need to tell that GUI to update, to redo the set clear color when we change the tweak. We already did that. We need to do GUI. After doing the add color, we can add the onChange method and send it a function. And if you want me to show you change, we can do just a change, like a log. And as you can see, every time we do some changes, we get this callback function being called. So it's working fine. And what we can do here is update the clear color of the renderer the same way we did here. Let me check. Yeah. All right. Now we can choose a better color. I'm going to go for this one because I know it's going to look great, but obviously you can use any color you'd like. It kind of depends on your scene, the mood of your scene. If you went for a kind of green mood or night mood, or I don't know, maybe it's all like red, like if it's in hell or something like that, you can change the color. For me, I'm just going to use this kind of a brown, dark brown color, which is better than the black default color. All right, cool. We can now take care of the fireflies. So it's the next step, a bit harder. We are going to use particles. We could have created like real 3D fireflies, or maybe just some planes like this to make the wings. But we will create something more simple but looking good, you will see, by using particles. And it's good for performances too. So yeah, let's go. Where am I going to put that? I think I can do it right after the model. Yeah, why not? So right before the sizes, I'm gonna do fireflies. And because I'm going to create particles, I'm going to put the fireflies at very specific position. I'm going to create my own geometry. So let's go. We can do like geometry like this. Const fireflies geometry equal new 3, and to create a new geometry, it's 3 buffer geometry. Like this. All right, I've created the geometry. We are going to fill this geometry with like random coordinates in space. First, I can decide how much fireflies I want. Const fireflies count 30. It's going to be enough. Obviously, you can change this value. We'll be able to tweak a lot of things in the end. Then we need an array in which we will store all the position of those particles, so all the position of the fireflies. So position array equal new, and we need to use the float 32 array. I'm going quite fast on those because we already seen that in the previous lessons. Go back to the particles lesson if you want to see how and why we are doing that. So here we need to specify the size of this array, and it's going to be the count of fireflies, so fireflies count multiplied by 3, because we need to provide 3 value for each particle, because it's x, y, and z. Those are the coordinates, so we need to multiply by 3. Later we are going to do another one, which is not going to be multiplied by 3. You will see. All right, it's time to fill this array, because right now all we have is this kind of big array. So it's 90, yeah, that's it, 90 values, completely empty, because we just asked to create this float 32 array, 90 values, and now we need to fill those values. So let's go for let I equal 0, I inferior to the count, I plus plus. So I'm just doing like a loop for each firefly, and for each firefly I'm going to fill that array. I'm going to add 3 values. So I'm going to fill this one, and this one for the first firefly, this one for the second, this one for the third, and it goes on like that. So position array at I multiplied by 3 plus 0. So this will be 0, 3, 6, 9, and it continues and it goes on and on. I'm going to put a mat random value, just some random value for now. I just want to see it before trying to place the fireflies at the right position. So this is the X value for each firefly. We need to specify the Y, and we need to specify the Z. All right. And if you test this, you should get something like that. Just random values. Yes, we could have done like a fully random, just from 0 to fireflies count multiplied by 3 and just put random value. But later we are going to tweak this and put a specific value for the X, a specific value for the Y, a specific value for the Z. So we do it 3 by 3, meaning for each firefly. All right. So this is a good array. Always make sure, what I recommend when you're handling this kind of arrays is to check. Oh, by the way, see? Check it. I did a mistake. Good thing I saw it. It's +2. My bad. You probably saw it, but it's 0, 1, 2. 0, 1, 2, 0, 1, 2, 0, 1, 2. All right, now it's fine. Check the beginning, check the end. Yeah, it's good. We have random value between 0 and 4. We're going to change those anyway. Okay, it's time to send this position array as an attribute to our geometry. So fireflies geometry set attribute, like that. We need to choose a name for this attribute that will be used inside the shaders. We don't have a choice. It has to be position because this is the attribute name 3GS is expecting. All right. If we have our custom attribute, which will be the case later, we can change and do anything we want. But this one is for 3GS. It will position the vertices. And we send this position array, but we have to convert it to a buffer attribute. So new 3 buffer attribute. We send this array, and don't forget that in the end you need to specify how many values per vertex. So for us it's 3 because x, y, z. So it's gonna be x, y, z of the first one, x, y, z of the second one, x, y, z of the third one. Yeah, I said we are not going to explain it again. Still, I want to explain it. Anyway, it's always good to see things multiple times. All right, cool. Looking great. I don't think we did any mistake here. We have our geometry. We are going to create now the material. Let's go. For now, we are going to use the default material, which is the point material, if you remember from the documentation, because it's good for the start. And later, we're going to change it to a shader material in order to be able to animate the fireflies in the vertex shader. Yes, we're going to do some animation in the vertex shader, just like the galaxy. It's kind of the same thing we are going to do. We are going to make the fireflies go up and down. And we are also going to change the pattern inside the fireflies, and we're going to draw it just like we did in the lesson, like shader patterns lesson. Yeah, I think that's the name. All right, cool. So let's go. Material, const fireflies material equal new 3 points material. So this is the default point material of 3GS, which is great. We need to choose a size. You can put just my values. Anyway, we are going to change those later. And we are going to also activate the size attenuation like this. All right. I think our material is fine. Size attenuation, let me check. I always get this one wrong. No, it's fine. Anyway, maybe we did some mistake. We're going to see that right after. Don't worry for that. We need to create the points, so let's go. Points, kind of the mesh, but for us it's points. Const, I'm not going to call it like points, I'm going to call it fireflies, because in the end, those are the fireflies. New 3.points, and I'm going to use the geometry we created first, the material, and nothing on the screen because as always I forgot to add it to the scene. Yeah, this one was on purpose. Scene add fireflies. Yeah, it's working. So though doesn't look yet like fireflies, but it's a good start. And I tried to put something on the screen before going further. And it's already quite a lot of code just to get those fireflies, those ugly fireflies. So yeah, try to do that. Put stuff on the screen and then iterate on it, improve it, improve it, improve it. First, we can change the position. So as you can see, it's a math random, meaning that it's a square. They are all in a square. If I add more, like 300, you will see that they are all in square, like this, because it's from 0 to 4, 0 to 4, and on this side too, 0 to 4. So it's not what we want. What we want is them to be like, we want them to be in the scene and not below the scene. So how can we do that? What we can do is math random minus 0.5. If you remember this, it's to get a value from minus 0.5 to positive 0.5, which is not enough because our scene can be like 4 units large. So I'm going to multiply this by 4. And I can do that on the X, but also on the Z, because it's a square seen from above. So how does it look? Yeah, it's looking good. The fireflies are a bit too high. We can reduce it a bit, like maybe 1.5, maybe 2. Yeah, I used 1.5 here. Yeah, it's fine. If you want them to go even higher, you can just by increasing this property here, this value here. All right, it's better. It's better. The custom shader material. Okay, let's go. we have our fireflies, we have the default behavior with the fireflies material. With the points material, sorry, we can change it to a custom material and create something even better. So let's go. First, what you can do is create those shaders. In the SRC folder, you can create a shaders folder, and we're going to have two shaders in this lesson, which is cool. We kind of mix shaders, so it's kind of a bigger project. In the shaders, we can create the fireflies folder. In this fireflies folder, we can create the vertex.glsl, and I'm going to show you here so that you can see more clearly. Yeah, see, it's looking like that. So this is our script.js file, shaders, fireflies, the vertex shader, and we can already create the fragment shader here, fragment.glsl, and those are already supported, yeah, so it's fine. What you can do here without looking at the screen, the bottom left corner, is try to write it on your own. It's a good exercise, it's hard. Sometimes I get it wrong, even though I did it like maybe 100, 200 times, but it's a good exercise. So I'm not looking down, main, something like that. We can start from a vec4, and we are going to separate the matrices. You don't need to separate the three matrices still. At least we need to separate the first one. So it's going to be model position equal, so it's going to be model matrix multiplied by the position. So it's the attribute we set here, but we need to convert it to vec4. So vec4 position 1.0 like this. All right, I think we got the first one. Maybe I'm doing some mistake, but anyway, let's do mistakes. It's the way to learn. The next one is going to be the view position. We are going to use the view matrix multiplied by what we got here, so the model position. And in the end, we need the projected, or let me check this one, projection. Okay, projection position, it's just about the name. I want to get the name right. Projection position is going to be the projection matrix multiplied by what we got here, like this. And I think it's fine. And we can send this one to GL position, yeah, equal this. And because those are particles, those are points, we also need to provide a size for those points. You might think, but yeah, we already put a point material with the size here, but we are going to get rid of this point material and use this custom shader. So we need to kind of redo what this material was already doing. So let's go GL point size and 40. Okay, let's use the value I put here. 40. Maybe I did some mistake. Let me check. Model position, model matrix, position, view matrix. Projection position, projection. Yeah, I got everything right. Okay, cool. Anyway, we can't see if we did a mistake here. We will see it later. And for the fragment, well, it's much more easy. Void main, like this. GL frag color equal, and we just put a value like, I don't know, maybe red. Is it red? Let me check. Yeah, we use some red. So 0.0, 0.0, 1.0. So this is RGB alpha. We want it to be visible, so we put the alpha to 1. I hope I got it right. What we can do now is import it inside our project, so inside our JavaScript. Import fireflies vertex shader. A bit long, but we're going to have another vertex and another fragment shader. So let's put the full name here. And the path is going to be this shaders. Why don't I have autocomplete? That's a good question. This is not looking good then. Let me check. No, it's working. I don't know why VS Code doesn't want me to provide me this autocomplete for the path. Maybe I got something wrong. No, it seems fine. Anyway, it's working, so let's go. The second one is going to be the fragment, sorry. So fragment, like this. and we can just log them to be sure that everything is working. So if we did a mistake in the vertex or the fragment, we can't see it. Right now we are just importing them. They are not being validated. We're going to use them inside the fragment materials, shader material, sorry. So we did import those. We get something like that. If you don't get something like that, just pause the video. Check the names of the file, the path of the files, everything like that. Check the error. You will probably get some information about the error. By the way, Webpack is already configured to handle GLSL file just like in the previous lessons. All right, cool. Well, we can get rid of this. And what we can do here is replace our points material by a shader material like this. And we can get rid of the size and size attenuation because those are properties specific to the points material. And right now we are using our custom shader material, so we can't provide those, but we can provide the vertex shader. It's going to be Firefly's vertex shader, and obviously the fragment shader. Don't mess up with the camel case. Yeah, I think it's fine. Let's test this. Yeah, on the first try, good. We get those even uglier fireflies. But now we have control. We are going to improve this a lot. All right, cool. If you don't get this, pause the video, check the errors, and then get back to the video. First, about the point size. We have a problem. It's that maybe some of you can see a different size. All right, it's totally normal. I'm going to explain what's happening. So for me, they have this size. On the side right here, you can't see it, but I'm looking at another screen with a different pixel ratio. If I move this experience on this other device and I refresh, the size is not the same of the particle. They are smaller. What's happening is that it depends on the pixel ratio. When we set 40 here, it's kind of 40 pixels. It's not really pixels, but let's simplify everything and say 40 pixels. But on a screen with high density pixel ratio, you have more pixels for the same space. Like if you take this space, you get more pixels inside this. So the particle will look smaller because 40 pixels, it's not that much, it's smaller, which is a problem for us because we want the particles to look the same, at least the same size on any screen, regardless of the pixel ratio. Many different ways to fix that. What I'm going to do is simply, it's what we did in another lesson, we're going to send the pixel ratio to the shader and simply multiply it here. Let's go. To send values to the shaders, we need uniforms. So let's go. Let's create a uniform. We are going to call it upixel ratio. There are many ways of handling that. Maybe you would have done differently. If you want to do it your way, do it. Just test on different screens, and otherwise you can do it my way. Value, and we need to provide the pixel ratio. We can get it from the renderer by doing renderer get pixel ratio, but we have a small problem here. It's just a JavaScript problem. Is that we are creating the material before the renderer. So we cannot call renderer get pixel ratio because the renderer doesn't exist yet. So I'm going to be lazy. I'm just going to take this code here. So it's math min window device pixel ratio 2. If you remember from the previous lesson, it's just because we don't use the pixel ratio. We limit it to 2 because some devices have a crazy pixel ratio like 5. It's totally useless. It's just marketing. It's bad for performances. It's bad for the battery, but they sell stuff saying we have a high pixel ratio. So just get rid of those kind of devices and don't buy it at the first place. Sorry for that. That was some kind of parenthesis. Anyway, we can just take this value and we are just limited it to 2. If you don't, you're going to have performances issues, but because you're going to have like a huge render for a small screen, so it's kind of a problem. So yeah, let's take this value, and I'm going to put it over here like that. All right, cool. Let me check. No error. This is good. We can get to the vertex, and use this value. So to retrieve a uniform, we do uniform, so it's singular. Float, because it's just one number, so one value. U pixel ratio, which is the name we chose right here. Don't forget the semicolon. And we can simply multiply this by the pixel ratio, like that. If your pixel ratio is 1, you will get 40. If your pixel ratio is 2, you will get 80. So the point should be bigger, but we have more pixels. In the end, you will get the same result. All right, you just multiply it by the pixel ratio and you're done. Okay, cool. So that's one way of doing it. There are other ways, but this one is kind of simple and logical. That's cool. What we can do to improve this just a bit is to also update it on the resize callback. Why I like to do that? Well, it's simply because if I move, I cannot show it to you, but if I move this window to the one on the side, it's too late because the pixel ratio is already set. And it's going to be the wrong pixel ratio. Like if I start the experience on this screen, which is a pixel ratio of 1, and I move it to the another screen with a pixel ratio of 2, for the shader, it's for the uniform, it will still be 1. So we need to update it. And we are kind of assuming that people, when they change a window from one screen to another, they resize the screen. They resize the window, sorry. So we are doing it. We are going to change this in the resize here, which is exactly what we done in the render like this. So yeah, let's go. We can update it. I can do something like update fireflies. Yeah, why not? Fireflies material. I access the uniform. The name of this uniform is uPixel ratio. I change its value. Don't forget the value. I always forget this one. And we just provide the pixel ratio. And if it's different, well, good thing. We did update it, the pixel ratio. So maybe I move it to a pixel ratio of 2. Then now this value will be 2. All right, just resize it. If you have multiple, like a screen with different pixel ratio, just move it from one screen to another. If you don't, just trust me. All right, cool. Let's go even further. Right now we have a problem, is that the size of the particles is always the same. It's 40. And that's all, because we said it's 40. So it stays 40. Even if the particle is far, even if it's small, it's going to be 40, which is not really realistic. We need to change that. And we are going to do what we did in the previous lesson. We are going to use the formula that we found in the 3GS shader chunks. So we took it from the 3GS dependency. We kind of dig, remember we dig in the shaders and we find this value here. I cannot explain it to you. It's kind of hard mathematics. For me, it's too hard. Maybe it's not hard, but for me, it's too hard. Anyway, here is the formula. What you need to do is multiply the GL point size by 1.0 divided by minus view position Z. So minus view position Z, like that. And if you check the result, so it's smaller, yes, but the one close to the view are big and the one far from the view are small. And if I get there, I can barely see them. And if I'm close, I can totally see them. All right, so we did reactivate the size attenuation using our own code. All right, cool. Next part, we want to control the size because right now they are a bit too small. So instead of changing this value right here, make a bigger value and just try to figure out the best value, we're going to create a uniform, send that uniform and use that uniform inside the vertex shader. So let's go. Just like we created like this uPixel ratio here, we can send the U size. Yeah, U point size, U size, it's up to you. So U size, those are our own custom uniforms. Value, and I'm going to send 100 and we will test other values later. All right, so U size, we can now retrieve this value in the shader. So it's going to be quite easy. U size, and instead of using this value here, we can put the U size value. What we get is bigger particles, because we set 100, and now we can add a tweak to be able to control that. So let's go. I'm going to put it after, yeah, why not? GUI add. So it's going to be Fireflies materials, uniforms, use size. So this is the object that contains the properties. The property is value. So it's that. And we need to provide a minimum value, 0, which is kind of strange, maybe 1 anyway. Maximum, let's say 500, we can change this later. A step to 1, we don't want like float values. It's not a problem. Name, and we're going to choose a name, and it's going to be Fireflies size. All right, a bit long. We provide a name because if we don't provide a name, it's going to be value, which is when we have a lot of tweaks, you're going to get lost in those. So provide a name. So for us, it's Fireflies size. And as you can see, we can control the size of the fireflies, which is cool. All right, we're going to change that later anyway. Next part, we're going to play with the pattern. Because right now it's just like a big square, red square. We need something much better than this. And we're going to do what we did in the previous lesson, in the pattern lesson. First, we need the coordinates, because in the shader pattern lesson, we had a plane. We sent the UV from the vertex to the fragment using the VUV varying. We might be tempted to do the same here, but it doesn't work exactly like that, because right now it's not planes, it's particles, and each vertex of the geometry will be one particle. So the WebGL will create some kind of two triangle here. So the question is, how can we send those UV coordinates? We don't need to do that because they are already available. We can access the UV coordinates of each square using GL point coord, like that. And see, we get the classic UV coordinates. So as you can see, I use the GL point coord. It's a vector too, so I use it on the X and Y of the vec3, and I then put the two last values. This one is for the alpha, and this one is for the RGB, so it's the B value. If you want the classic UV pattern that I really like, you can put one here, and this is the classic, like kind of purple, bluish pattern for the UV coordinates. So remember, when you want to access the UV coordinates in a particle, it's using GL point coord, like this. And now we can draw the pattern. Maybe you want to try right now. It's up to you. But anyway, we're going to do it together. We want some kind of like a point of light, like really bright at the center, and then it's diffused quite fast, and we get some kind of radial point light like this. Okay, first we're going to need the distance to the center. All right. So let's go. I'm going to create a new variable, float distance to center equal, and we're going to use the distance function, and it's going to be the distance of the coordinates, so the GL point coordinate to the center, and the center is 0.5, 0.5. So let's go, vec2, 0.5. We can just provide one value here, and it's going to be used for the X and Y. Okay, no error, yeah, looking good, but we didn't use this value. What we can do here is send this value to the alpha. So we're going to put everything in white. So this is white. See, I've removed my GL point coord, so this is fully white. And I'm going to use the distance to center. So supposedly it's going to be like 0 more, maybe 0.5, and even more here. So we want to send this to the alpha, just to make sure that it's working. And it's not working because we forgot something. Can you guess what? It's been a while. We forgot to set the transparent to true. On every materials, you need to set, this one is transparent, this one is not transparent, this one is transparent. By default, it's not transparent. So let's fix that. Here we can provide transparent, true. And now our material is handling the transparency. And we get something like that. So it's the exact opposite of what we wanted. still, it's a good start. All right. Yeah, the pattern we want. So I'm not able to explain it, but I've been using it a lot to get this kind of high value, and then it drops quite fast. We're going to start from a very small value and divide it by the distance. And I can show it to you in some kind of math graph. So this is just like a representation to see things a bit more. So we have from 0 to 1. If I provide x, you see that x is like just increasing. All right, okay, that's cool. So this is the value just increasing. This is kind of the distance from the center. So see, it's just getting bigger. What I want is something like really high, like 1, and then it drops really fast, like this. I want a curve like this. And I want it to be like really high here and drops fast. What I can do is start, just as I said before, start from a small value, like, I don't know, maybe 0.2. We're going to use even smaller and divide it by the distance. So for us here, it's x. And as you can see, so you can ignore everything below 0 because our distance right here, our distance is always, oops, this one is always positive. So it's 0 at the center of here, and it's just increasing. So it's x. And it's always positive. And we get a value that will be really high and drops really fast and gets really low, which is probably what we want. We are going to have a problem here, but it looks like this is what we want. So you start, it's a kind of classic formula. You start from a small value and you divide it by something that increases. So for us, it's x, and here it's going to be the distance from the center. Let's go. We can try this. We're going to have a problem, but anyway, you will see. What we can do is create another variable. I'm going to use strength equal, and I'm going to start with an even smaller value. It's going to be 0.05 divided by the distance to center, like that. Okay, and I'm going to use this strength here instead of the distance to the center. And here you go. And it's looking good. See the pattern we have? It's really high. And then it drops really fast, like this. And you get something like that. So it's really high. It's way above 0, where I have my cursor right here. Way above 0. Way above 1. Way above 1. Now it's 1, and now it's dropping. It's dropping really fast, like that. But, as you can see, we can see the edges. What's happening here? Well, it's simple. Look at this graph. Let me check. Like this. It never reaches 0. Even in, like, as far as possible like this, it never reaches 0, which is why we can see the edges. So how can we fix that? Well, there is kind of a simple trick here. We can just do minus 0.2. Like that. We move this curve here down. So it was doing that, and we did that by doing just minus 0.2. If I do more, minus 0.4, we get this. The question is, what's the real value we have to put? It's not minus, so it's, you can see that 0.2 minus 0.2. So maybe we can do that, minus 0.2, and you will see that it's not totally right. We can still see the edges. I don't know if you can see, maybe let me find one. Yeah, see, we can still see the edges because we have to double it, because when we reach the edge here, the distance to center is equal to 0.5, not 1. So here we did the same value here, we did minus the same value, so that we can reach 0 when x is equal to 1. Alright, so it did work in that case, but for the distance to center here, we have to reach 0 when it's 0.5, when this value is 0.5. It's quite simple to fix that. We just need to double this value. Alright, so because we put 0.05 here, we need to put the double of this, so it's multiplied by 0.2. And now it's working. And if you prefer, you can just provide 0.1, all right? We don't need this kind of formula. You can just do the double. Actually, I would have done like this because I like it clear. If I want to change it, I can change it like that, change the value like this. I can change both. So I can do that, I can do that, and it's faster, which is why I like to keep this multiplied by 2. All right, I like to keep this formula, but if you want, you can just provide 0.1 like this. All right, I'm going to keep this one. Okay, so it's looking really good. I like those fireflies. I think I would have let it like this. No, we need some improvements. You will see what. So yeah, we did fix that. Okay, that's cool. Yeah, first we need to add more randomness about the scale, because right now all the fireflies have the same size. They look good, but they could look better. And when you try to create something like organic, like natural, you need to add randomness. If you look at, I don't know, a forest, if all the trees are exactly the same, they have the same size, the same color, the same branches and stuff like that, you will know there is something wrong. They have to rotate, they have to bend, they have to change their color, their size, stuff like that. So you need to add randomness. Here it's the same thing. We need to add more randomness to make it more convincing. We're going to scale them randomly. So some of them are going to be small and some of them are going to be bigger. So let's go. What we're going to do to provide this is use another attribute. So let's go. We're going to create a new one. So const scale array. We're going to provide a scale for each one. New float 32 array. It's going to be the fireflies count multiplied by just 1, because we need to provide one value for each firefly. So we can get rid of this. We just provide one scale. So it's going to be 0.5, 0.8, 0.2, 0.35, this kind of thing. So it's just one value per vertex. Here we can update it. So we are going to do something like scale array I equal just a random value from 0 to 1. And in the end, we also need to provide this the attribute. So it's going to be, we can name it the way we want. So it's going to be A scale. I like to start with A for attribute. And it's going to be the same kind of thing. So buffer attribute, we provide the scale here. And there is only one value per vertex. It's what we did here. There is only one value per vertex. As always, just test what you did. I kind of tend to do mistake here. Yes, I have random values. It's looking good. And as much values as fireflies. So yeah, this one seems good. We can use it in the vertex shader. It's going to be really easy. What we need to do is retrieve the value. So attribute float A scale, like this, and we can use it here. So use size multiplied by A scale multiplied by U pixel ratio. The order is not important. You can put it anywhere you want. It's going to be the same. But I like this order because it's logical. We start from a base value for all of them. We applied a custom one, and in the end, it's kind of different from, it's more like a screen related and stuff like that. So this is the kind of order I like, but you can totally change the order. It's not important. And here is the result. And now we have big one, we have a small one, we have very small one, and we get some randomness. And it's looking good. Maybe too small. We can change that. Actually, I think we are going to do that right after, but still it's looking good. We have more randomness. All right, next part, we can add some blending. Yes, they are looking good. But if you remember, we can use the additive blending to make them more kind of shiny, like if they are light, which is exactly what we want. We want them to look like points of light. When using the additive blending, it's going to add the color to what's behind, which is a good looking result. Let's go. It's on the material. So the material is over here, and we can just add blending 3 additive blending. We did it, I think it was with the galaxy. And now it's even better. See how it merges with the colors like this? It's adding the color of the firefly to what's behind, and it's looking really cool. Even more convincing. Alright, be careful, additive blending is bad for performances. But we don't have much fireflies here. The performances are going to be great, don't worry. We have a problem. Let me check if I can show you this problem. Yeah, this one is not bad. We can see it. Maybe we can see it on this one. No, unfortunately. Let me find a better one. Yeah, see this one? It's good. See what's happening here? The particle you can see here, follow my cursor, this one, look when I move it in front of the other. So there is one like close to the floor here, and this one, so the big one in front of us, is hiding the one behind. What's happening here? It's exactly what we saw in the particles lesson. It's because this particle is in front of this one, so this one is not supposed to be drawn. Yes, this one is transparent, but for the GPU, it's in front of it, there is something hiding, it's get hidden. There are solutions, many solutions to fix that, and we're going to use the really like straightforward one. It's going to be to deactivate the depth writing. We're going to say to this one, you draw yourself, and you don't like take the place, you don't provide this information to the depth buffer like, now there is something hiding the rest behind it. This is the depth writing. When you draw stuff, it's the WebGL we save in the depth buffer. All right, there is something here, and there is something here. And if something is trying to be drawn behind, the GPU we say, no, there is something here in front of it. It's exactly what's happening here. There is something in front of it, so don't draw it. We're going to say, no, don't remember what is being drawn when it comes to those. So they will be drawn, but like if there is nothing, if something tries to be drawn behind, it will be drawn. So this is the depth write. And to fix that, we can do depth write false. We deactivate the depth writing. Let's see if it's working now. Let's try to find one with a bug. So obviously we won't be able to find one. See, they're working nicely. I cannot find anyone with this bug because there is no bug anymore. And see how they are merging. Yeah, I really like the blending. This is because of the blending. Looks really cool. Anyway, problem fixed. Next part is about the floating animation. We want to add more life. It's already good, but we want to add more life to those fireflies. We're going to make them move up and down, like this. Just up and down, not too much, not flying around something. Those are not flies flying around garbage. We just want them to move up and down. So let's go. First, because it's going to be animate through time, we need to provide the time to the shader. We're not going to animate them in the JavaScript, we are going to animate them in the vertex, so we need to send the time to this vertex. So let's go. I'm going to put it in the beginning. I like to put this value in the beginning because it's kind of the main uniform we can use for many stuff inside the shader, so I always put it at the start of the uniform. It's not that important, you can put it anywhere you want, it's the same. We provide 0. And later, in the tick function, we update it. So let me check. Yeah, that's it. We already have the elapsed time in the code, so I can show you what we get here. It's from the clock instance, and we just get how many seconds has been spent since we kind of shown the experience. All right, cool. We want this, so we are going to update the uniform. So it's going to be update materials. Fireflies, material, uniforms, uTime, value equal elapsed time. We just send this elapsed time to the uniform we just created. So fireflies material, uniforms, uTime, value, don't forget the value, equal elapsed time. Did I do a mistake? Did I do a mistake? No. All right, looking good. We can now retrieve this value here. So I'm going to do uniform float. It's a float uTime, just like that, just making sure everything is working. Still working. Great. I just want to make sure it's working. What I like to do here is simply model position, I don't know, x plus equal uTime, and you will see that it's going to leave. Yeah, it's working. See, they are moving. And the distance, it's just the uTime, and the uTime is 0, 1, 2, 3, so they are moving away. All right, cool. But it's not the animation we want. Maybe they are just leaving, but it's not what we want. We want them to move up and down, so it's going to be on the Y. Better. And instead of doing that, we are going to use a sin, because the sin, we do something like that. Remember the sinus? We can use it to make some kind of wave animation, like this. It's going up and down with any value you provide. So it's going to be the time. So I'm going to do sin u time, like this. And it's working good, but they are all synchronized. So thank you, the fireflies, but you are way too synchronized. We need to add randomness. What can we do here? There are many solutions. We could have sent another attribute. The more attributes you send, the more uniform attributes, texture, stuff like that to your shader you send, the worse for the performances. All right, so try to reuse what you already have. You could have sent it one. We don't have much fireflies, but still I want to show you this. Instead of sending a new attribute to add some randomness here, so that this one is going to be, I don't know, +1, +2, +3, something like that, we can use other value. And because they are not moving like this, or like this, I'm going to use the position on the X to add randomness to the sinus. It's going to be model position X. I'm using the position on the X, so this one has I don't know, maybe minus 0. Maybe minus 1.5. This one is going to be minus 0.5. This one is going to be 0.8. So they have different value on the X because it's just their position. So I'm going to use that, but the value is too small, and see, they're kind of doing this dance like that. So it's not random enough. I'm just going to multiply it by a huge number, like 100. And now it's fully random. I mean, it looks like it, but we get a good result. We just did something like that. See? It's just so big that one particle will be here, one will be here, one will be here in terms of time, and we get something that looks totally random. All right, it's good, but they are going way too far, and it's always the same amplitude, because a sinus gives you something from 0, let me show you, from -1 to 1, right? It's always from -1 to 1, -1 to 1. So they are all going from -1 to 1, -1 to 1. All right, to fix that, yet again, we can send a new attribute, or we can use what we already have, and we already have the scale. Instead, we could have played with the model position Z. That would have been a good idea. Like, we could have multiplied the sinus by model position Z. So it's going to be this value. So this one is here, this one is here, this one is here. This is the Z axis. This is a good idea, but instead we are going to do it quite differently. We're going to multiply by A scale. If you remember, the A scale is what we use to control the size of the point. This way, the small fireflies will move less and the big fireflies will move a lot. Cool. That's another way of doing it. Obviously it's way too much. We're going to multiply it by 0.2 anyway. And it's looking really cool now. The smallest particles, see there, are just moving just slightly, like this. But the big particles, like, yeah, there is one here. This one is moving way more. And this one, there is some, yeah, this one is moving a lot. Yes, some of them are going through the floor, but it's fine. We can fix it, like from the position, stuff like that, but anyway, it's fine. We didn't use any tweaks here, but obviously you can add tweaks to control this animation. All right, you can control the speed of time. If you multiply it, I don't know, by 10, we see that they are going to be crazy. Yay! So you can add uniforms to be able to control those kind of things, the frequency, the amplitude, etc. All right, cool. Let's move forward. And we are done with the fireflies, and they look really cool. I'm really happy with the result. Really convincing and simple, and the performances are good. We're going to take care of the portal, and this one is going to be fun. We're going to draw something, because right now this uniform color is quite convincing, but not very interesting. Keep in mind that still we chose a color which is white, and we need it to be that color. Maybe for you it's red, green, so in the end we need to get that color. But we are going to do some mixes, some cool patterns in it anyway. First, we can create some shaders. So let's go. We can already do that. So inside the shaders folder, you're going to create a portal folder. I told you we are going to have two sets of shaders. So we did the fireflies. Now we are going to do the portal. So we can create the vertex.glsl. Let me show you like this, so you can see what I'm doing exactly. So shaders, we already have these shaders folder. Portal vertex.glsl, and again fragment.glsl. All right, we can write the classic void main. Let's try to do it quick. vec4, you can copy and paste it from the fireflies, but it's a good exercise. Position it equal modern matrix multiplied by vec4. We can do a race. Let's see who got it first without doing a mistake. So view position equal view matrix multiplied by what we created here. vec4, I think it's projection. Yeah, we did projection. Position equal projection matrix multiplied by what we got here. We don't need to provide any GL point size because this is not a point. This is a classic geometry. And we can set the GL position in the end using this projection position. All right, we can shorten this part, I know, but at least it's clear. And in the fragment, I think it's going to be like a just red pattern, red color as always. So GL frag color equal vec4 1.0, 0.0, 0.0, 1.0, so that it's visible. All right, that was quite fast. Let me check. Yeah, that's good. I think it's fine. And the other one, yeah, it's just red. All right, cool. Pause the video if you need time. You can copy and paste from the fireflies. Let's move forward. First, what we can do is import those new shaders inside our project. I'm going to be lazy and copy and paste the fireflies here. And I'm going to replace fireflies by portal. Oops, portal, like this. I can test those. So as always, it's always good to make sure that everything is working. Like this. And it's fine. Pause the video if I'm going too fast, but we did exactly what we did when we started the shaders for the fireflies. Next part, so I can hide the sidebar like this. Next part is going to be to change the portal. We already have the material set. We did it in the previous lesson. Remember, we changed it to a mesh basic material so that we can have like a full color like this. So we can change this one. It's going to be the portal light material. We can change it to the shader material like this. We can't provide a color like this. We need to provide the vertex shader. So it's going to be portal vertex shader. And the fragment shader is going to be portal fragment shader. Let's see if we did something wrong. No, it's fine. See, we get exactly what we want, which means the geometry where it should be. We're not going to play with the geometry. We could have. That could have been fun, but the pattern is already a good exercise, so we are just going to play with the pattern. So we don't need the vertex anymore. We can just close it, and we're going to draw things. Oh no, don't close the vertex. We're going to need it just to get something from it. And here we're going to draw something cool inside of it, inside of the portal. So yeah, let's go. We're going to use the UV coordinate to draw on the portal. Very similar to what we did in the patterns, shader patterns lesson. First, we need to send the UV coordinate to the fragment. So this is why we need the vertex a bit more. We're going to create the varying. Remember, in the vertex, we already have access to the UV coordinate by default because it's a shader material, and in a shader material you already have the position, the UV, the normal and stuff like that. So we already have something, so don't do it, but there is something like attribute UV so sorry, vec2 UV, something like that, being prefixed in the shader. But we want to send it to the fragment, and to send stuff from the vertex to the fragment, we need varying. So varying vec2. We can't call it UV because it's already an attribute named UV. We can call it VUV. I like to do that because V for varying. That's cool. We can update it. Well, anyway, it's not that important. We can do it here. VUV equal UV. So we get the attribute. We just send it to the UV. Here we have a warning telling us that we created a VUV, but we are not using it. It's because it's bad for performances. Don't worry, it's okay. We can totally do that. But 3GS is trying to help us, like, be careful, you did that and you're not using it. So don't mind this warning. To retrieve it in the fragment, we can simply write varying vec2 VUV. So it's exactly the same as in the vertex. And now here in the fragment, we have access to the UV coordinates. And what we're going to do is put it there, right here. Let me check. Yeah, we can set this one to 1 to get this beautiful usual the usual gradient, and it looks like this. If you have a different gradient, like I don't know, maybe the pink, sorry, is on the left or top or bottom, it's okay, we don't care, because we're going to do something like circular. If you get only one color, like a uniform color, it's probably because your UV is not unwrapped. And I'm going to show you how to fix that. So if you get a gradient, any gradient, like even if different from that, I mean it's rotated differently, it's fine. Don't do what I'm going to do. But if you use your own model and you get something strange like a uniform color, follow me. We're going to fix that. The problem is that your portal is not unwrapped properly because the UV are the UV coordinates. It's about unwrapping. So maybe you get something different from this. So right now what I can do is deactivate this. Maybe for you it's not activated. Let me check. How can I get it? Oh, it's too far. Here it is. Okay, like that. So you're supposed to have this. So go in your file. Sorry, I went a bit far. Activate the emission if it's not activated. You can let the rest activated. It's not a problem. Just don't activate the selection on the other. Select your portal, and you should have something like that. But you probably have something else. Like I don't know. Maybe you have nothing. Like maybe it's totally invisible. You have nothing. Okay. When you edit and select every faces, you get nothing. Maybe you get something like, let me check if I can get you this, like that. Anyway, if you don't have this circle, it's UV unwrap problem. How to unwrap it? It's very easy. You just select all the faces, you do U and unwrap, and you're done. That's all. We just need these coordinates here, and it's exactly what we want. The mistake you might have done to not have this unwrap is maybe you created like the circle. You did choose, I don't know, maybe triangle, but you uncheck the generate UV. All right, maybe that's the mistake. And as you can see, there is no UV here. If I create it again, I do circle, I choose triangle fan, sorry, generate UVs. And if I change it, I go to in the edit mode, you can see that I have my UV coordinates. Maybe that's the mistake. Anyway, once you get this, it's time to export everything again. So we are going to export the emissions, make sure the names are right, the baked, like this. You can just select everything like that. So this is the merge version. It has to be named baked. It's what we did in the previous lesson. And you export everything. I'm going to do it just to make sure everything is working. Did I unwrap it? Yeah. So I select everything, export, GLTF, GLB, and GLB, GLTF. Make sure you have the same parameters. I'm not going to use the compression because, as you saw in the previous lessons, it's going to bug on this version of Blender. And update the right, so it's not this one. For me, it's going to be 36. Oops. Like that. Exercise static, and it's in the static folder, and you name it portal.jb. We just export it again. That's all, with everything in it. All right, we get back here, and we get this. You're supposed to have this. If you still don't have this, you probably did another mistake. Anyway, let's move forward. So pause the video, fix the mistake, and let's move forward. Yeah, this is exactly what we did. All right, we're going to use some pairing because we need this portal to be alive. We want some stuff happening in here, like, I don't know, it's kind of living. Yeah, we just want to add more life to it. We're going to use a pairing. It's going to be the same pairings as we used before. We're going to use a 3D pairing, even if these are 2D coordinates. Why we are doing this? Well, it's because we're going to play with the third value of the pairing to change it in time. You will see the result soon, but we are going to use a 3D pairing noise to be able to play with the pattern with the time. So the pattern will just change with time. You will see. It's not going to be one pattern like this. It's going to change with time. So let's go. What we're going to do is use the classic pairing 3D noise by Stefan Gustafsson, which did such a great job. Everybody using this code. Thank you, Stefan. And you can find it on the usual gist. So it's here. So check the links as always. And it's this one. Let me check. Yeah, so not this one. This is the 2D noise. We want the 3D noise. So it's this one. You can copy and paste the whole code. It's going to work. Or you can take it from the lesson. Just scroll down on the page you're watching right now and take the code. And me, I'm going to be lazy and take it from here. Up, like that. And I'm going to put it before my main, in the fragment. So we can close the vertex in the fragment before my main function. All right, I know it's a lot of code added to your code. There are solutions like includes, you can use a JSLFI, stuff like that, but I don't mind having this kind of code here. All right, cool. Just make sure things are still working. If you get an error, you probably copy and paste something wrong. Okay, we are not using this noise yet. Just make sure everything is still working when you passed the code here. And it's right before the main. It doesn't really matter. As long as it's before the main, it's going to be fine. Okay, cool. So first, let's use it. We want to see this pairing noise to start with. We're going to create a strength value. So it's going to be strength equal, and the name is C noise. All right, it's just the name that Stefan Gustafsson chose. I don't know if it created this one exactly, but he created the algorithm at least. And we need to provide a vector 3. It's what I told you right before. We are going to send 3D coordinates, but right now all we have is those VUV coordinates. Yes, so we are going to start with that and add a third value. So let's go. Anyway, we need to provide a vec3, so vec3. Don't forget the semicolon at the end. The two first values are going to be vuv.x, vuv.y, and for the third value we're going to use 0 for now, but later we're going to update it. We can test the result by sending it to the GLFrag color, so the first value, the second value, and the third value, just to make sure that it's working. And we get something like that. No error, but I can't see much. It's because the coordinates are a bit too, they don't change much. It goes from 0 to 1. We can see a lot of variation here. What we can do is multiply by something, like, I don't know, 5 should be fine. And we get this. And now we can see the pattern. And now it's starting to look like something. Small tip, when you are sending like, see it's a VUV, the X and the Y. Inside, let me just show you like this. Like, see it's a vector 3. The first two values are the VUV. You can just provide VUV. And this is going to be the first two values because VUV is just two values, X and Y. Then on the vector 3, the first two values are going to be VUVX and VUVY. You don't need to write VUVX and VUVY. And the third value, which is 0. And you can multiply it by 5.0. It's the same. All right, we just wrote the same thing. And see this pattern, try to remember it. So we have like big stain here, one here, one here. And if I change this value, I don't know, to 100, see it's totally different. It's not the same pattern. So we need to play with this one. So let's go. what we are going to do is send the time so that this value here is going to change with time. So let's go. We're going to the material here. I'm going to send the uniform. So uniforms with an S. Don't forget the comma. U time, as always, value 0. We just set it to 0 to start with. In the tick function, we update it, and we already did that here. So we can just duplicate this, change the name. So I duplicated the Fireflies material uniform U time value equal elapsed time. I duplicate it, and I change the name to do it for the Porter Light material. No error. Let's move forward. So we did send a uniform, but we are not using it. First, we can retrieve the uniform. I like to do it at the beginning. So uniform float U time. I always forget to specify the type. So uniform float U time. All right, still no error. Looking good. Going well. And we can change the third value of the vec3. So we did put 0. Now we can change it to U time. And look at that. Now we are talking. See that? It's already looking like Stargate. Yeah, it's really cool. We're going to do even better, but it's a good start. And I love to play with Perlin noise. It's too easy. It's just too easy to get something looking good with Perlin noise. It's kind of cheating. So this is good. It's going a bit too fast, but we're going to fix that. Yeah. The next part, we're going to start with this one. Let me check if we did some other changes. No, it's like that. So right now it's black and white. Maybe you have some colors. We're going to fix that in the end. We start with the pattern. We focus on a black and white pattern, and in the end, we change it to the colors you want, and we will be able to tweak those colors. The first thing I want to show you, it's how to displace the UV. We are going to play with the UV and displace the UV. You will see what I mean by that. I can try to explain it to you for like 10 minutes. You won't understand, but if you see it, you will see the result. You will probably understand. So we are going to displace the UV, and I'm going to show you what you get. First, we're going to create a new UV coordinate. So it's going to be displaced UV equal, and we start from the VUV like this, but we add another noise to it. So we see this C noise, we can take the exact same thing. We take this C noise and we add it to the VUV, and it's going to be added to the X and to the Y. The C noise is it's returning a value, a float value. When you do a vector 2 plus a float, it will be added to the X and the Y. And I'm going to show you what you get here. So maybe I can just check no error. Great. We can forget for the strength for just a moment. See, I'm going to show you. You don't have to do it. I just want to show you. You can do it, but I just want to show you what you get. We're going to do displace UV 1.0, 1.0 like that. And see, this is now our UV coordinates. So initially it was that, static, just a gradient, and we add the noise to this UV coordinate, and we get something like that. So we are messing with the coordinates, and you see that it will look really cool. So I get back to what I had before, so Command Z, undo, 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 like that. And in the strength, instead, I can add just a comment like Perlin noise. Instead of using the VUV coordinate, we're going to use those new displaced coordinates you just saw right before. And you will see that we get something like that. And it's looking even better. It's too fast, too much details. We are going to improve that, but the pattern is really cool. Like right now, it's really cool result. So how to improve this? First, it's going too fast. So we can lower the U time. We can just multiply it by something below 1. So we do, I don't know, maybe 0.2, like this. So it's already much better. You want the user to be able to just like enjoy the patterns and maybe, oh, there is a bear, there is a guy here, there is a monster here. So you can just enjoy the patterns. And we are going to do something else. We are going to provide 2 different frequencies for the time to add more randomness. So this one is like like displacing the UV, and this one is just showing like black and white. I'm going to change this one and do 0.1. And now we get a pattern that changes through time. It's even more random, and it's even harder to feel like a repetition. You won't be able to see the same pattern twice, that's for sure. Yeah, it's like, it feels like it's living, which is great. All right, cool. Let's move forward. So always provide just different values. We can also like play with the here, like, I don't know, maybe we put 10 and see we get something even more strange. Maybe more. I just want to test like 40. Oh, what's that? It's not moving enough, but it's crazy. Okay, cool. Maybe 2. I just want to test some stuff. No, this is too large. Still, it's looking good. All right, let's skip 5. I want to follow the what I planned initially. And it's great, but there is like a main concern here. It's that initially it was like bright, like one fully a bright color. And on the side you can see that because it's bright here, because the portal was close to those parts of the bricks, and they are supposed to be like really like being lightened up by the portal like 100%. But the portal is now mostly black, so it's not good. We have a problem here. We want like an outer glow. We want it to be white on the side. We still want to keep this pattern, but only in the center, and be less of this pattern on the sides. We want it kind of a outer glow here. How can we do that? Well, it's kind of classic from the center, distance from the center pattern. So to do that, what I can do is right below, we are going to calculate the outer glow, and we're going to focus just on the outer glow. I don't try to mix everything. Here we have a displaced UV, here we have the strength, now we have the outer glow. Don't try to put everything and mix them now. Just focus on each one, just like we focused on the displaced UV when we wanted to do it, just like we focused on dispelling noise when we wanted to do it. Here we are going to create like a float outer glow, and we are going to send it right away to the frag color, just to be able to see this value only. So it's classic like distance. We want the distance from the VUV to the center, and the center is vec to 0.5 like that. And we can just send it instead of the strength. So this code is not used anymore. All right, we are just focusing on the outer glow. Once we are happy with the outer glow, we are going to mix it with what we had before. And it's looking like that, and it's almost what we want. As you can see, it's brighter on the side and like totally dark at the exact center, which is good. We get some kind of radial gradient. Okay, so how to improve that? First, we want it to be like fully white on the side and to drop quickly. All right, so fully white on the side and drop to black quickly, like much faster. We are just going to test values, to multiply it, to offset it until we are happy. Maybe there is some mathematics solution and it has to be like that. Me, I'm bad at math. I would just multiply it, add it, subtract it until I'm happy. So I can multiply it, I don't know, by 3. All right, it's already much better. See, it's going to 1 much faster. Maybe I'm going to add, I don't know, 1.0. Oh, it's the opposite. It got even like smaller, so it's not add, it's maybe less. Okay, now it's pretty good. Maybe it's not enough. Maybe I can add more, like, let me check. Oh yeah, it's 5. So 5, and I'm going to use those values, and it's 1.4. Just test until you're happy. And you can change those later anyway. Here is the ID. We get this. So as you can see on the side, it's fully bright. Perfect. And in the center, it's getting darker. So now it's more logical in terms of like how the scene is being illuminated. Cool. What we can do now is mix the strength we had before with the outer glow. So I don't know, maybe you can just do like strength plus equal outer glow, maybe like that, I don't know. I'm adding the outer glow to the strength, and I forgot to put back the strength in the GL flag color, so I can just change that. And yeah, it's looking good. But we have a small issue here. See, it's working, so it's dark in the center and less dark on the outside, but we can still see some black on the outside. This is because the Perlin noise, at least the one we use, which is the Stefan Gustafsson Perlin noise, doesn't go from -1 to +1. It's not even from 0 to 1. It goes from values to values, and those values can go below -1 and above +1. So it's kind of hard to handle those. Could have limit those or not. Anyway, keep it that way, because the next part is going to fix that. So I know we have some black on the sides, but the next part is going to fix that anyway. And the next part is going to be the step function, and you will see why. First, the reason. Right now it's looking really cool, but there is something I don't like. It's that it's not sharp enough. See, it's really smooth, like organic, like some kind of like in Stargate, it's just some kind of water doing that, which is cool, but it doesn't match the scene. See, we have sharp rocks, sharp fences. It's kind of low poly stuff. It doesn't match the rest. To fix that, we're going to use the step. If you remember the step function, you provide a value, and if the value goes above a limit, it's going to be 1. And if it's below the limit, it's going to be 0. Like if you had a scene formula, it's going to be 1, 0, 1, 0. It's 0 or 1 depending to a limit. You provide the limit, and if the value is below it, stay as 0, and puff, 1. So this is the step function. The idea is that we are going to start from this pattern, and if it's above this value, it's going to be 1, and if it's not above the value, it's below this value, it's going to be 0. Best thing to show you that is just to do it. You will understand easily. So apply a cool step. Yeah, why not? Strength equal. We use the step, so now the strength is going to be equal to the result of the step. You can add the semicolon already. I don't know, maybe 0.0, because the value can go below 0 and above 0. So I don't know, let's start with the limit at 0. This is called the edge. All right, this parameter is called the edge. And we use the strength. So the strength is what you can see here. And we are just saying, like, if it's below 0, it's going to be 0. If it's above 0, it's going to be that. And it's looking like that. And it's looking really cool. See how great the pattern is? But it's too sharp. Me, I really like this one, but it's now looking way too sharp. We need to kind of mix from the previous one with the new one. First, let's change the value. I'm going to use the value I provided here, which is -0.2. Let me check why. I don't know. Yeah, it's just slightly different. I think there is no chance to have some black on the sides. Yeah, this is why. So -0.2 gives you some good result. Anyway, if there is some black touching the side, it's okay. What we're going to do is, instead of like converting the strength using this step, we are going just to mix them. So we're going to do strength equal strength plus the step, and it's going to look something like that. Look at this. We get a mix. So we start from the strength and we add a sharp version of this strength. And it's looking really cool. Maybe the sharp version, so this one is too strong. What you can do is lower it a bit, like, yeah, exactly 0.8. And now you can see even more like the smooth version. If you put less, like 0.5, you will see even more the small version, but we can't see much like the edge of the sharp version. So I like 0.8. By the way, when you do like strength equals strength plus something, obviously you can just write strength plus equal this value. It's the same thing, like in JavaScript and stuff like that. And it's looking really cool. Yeah, I really like this one. Like, it's really organic. We have some black going like on the sides. Maybe we can just tweak the values to get a better result, but I don't mind. For me, it's just fine. So we are almost done here. We need to be able to tweak the colors because some of you probably have very different colors. You can't wait to see with your colors. So now it's time to change that. Okay, let's go. First, we are going to add uniforms because we are going to send those colors and be able to tweak them. So let's go. It's going to be, no, it's not here. My bad. It's over there. Yeah. We are going to have two colors, one for the inside, one for the outside. So color start. We provide a value and it's going to be new 3.color, and we're going to start with a simple color like red. And for this one, it's going to be color N and it's going to be blue, obviously, just to start with something. All right, cool. Yes, it's working good. We can remove this comma. In the fragment, we can retrieve those. So here we are going to do, so it's a vec3 because RGB. So color start, color end, still no error. And we can use them. And can you guess how we are going to use them without watching the bottom left corner of the screen? We are going to use a mix. We are going to mix between one color and another color according to the strength. Meaning that if the strength is low, it's going to be the start color, so color start. And if the strength is high, it's going to be the other one. We are going to mix them. You have two like a pot of paint, and if the strength is high, well, you put this one, and if the strength is low, you put this one. And if it's right below them, you put as much of the two. So let's go. The final color, vec3, so dramatic. It's the final color. color start. So you provide the two colors. So it's color start, color end, and the value that mixes those. And for us, it's the strength. Let's see if I did some mistake. No, we can now use this color. Instead of putting the strength here, we're going to provide the color. Remember that JFrag color is a vec4. The RGB color are going to be what we just created here. And the alpha stays 1. We don't want to be able to see through the portal. And you get something like that. So it's working. Red at the center, blue on the outside, but we are going to change those colors. To do that, we're going to add those to the debug object, just like we did for the set clear color. I'm going to do it, let me check. Yeah, we can do it right after creating the portal light material. So debug object. Portal, color, start, yeah, something like that. So I'm going to use a string. That GUI has some bug when you don't use a string, so I recommend to use more like string, like hexadecimal string color. So we have the start, we have the end. For now, we provide the same colors, but we will be able to change those right after. No, I'm doing a mistake here. Yeah, you have to do that before the material because we are going to use them inside the material. So put the debug properties before creating the shader material. My bad. And then we can do a GUI, add color. I'm going to put it with a line break. So it's our debug object. We just created those properties. Now we want to be able to tweak them. So it's going to be debug object. The name of the property is portal color start. We're going to do one and then the other one. So I can just test this. Yeah, it's working. So this is this property being tweakable. We can listen to the change event by doing that, just like we did for the set clear color. Changed. And when I change this color, well, this callback is being called. Cool. And what we can do now is update this uniform. I know we are doing it before, but don't worry, this event will happen after. So it's fine. In terms of time, it will happen after, and this variable will exist. So it's fine. So portal light material uniforms, color start, value. And when you have like a color, like a 3JS color, you can simply use the set And in the set method, you can send anything like a red or this hexadecimal or RGB or stuff like that. So it's cool. We're going to simply use the debug object portal color start. So it's the one we just tweaked. And let me show you the result. Oops, like that. And see, we can change the color and it's working just fine. Okay, that's cool. That's perfect. We can duplicate everything. Yeah, I mean, not everything, but GUI add color. So it's not going to be start, it's going to be end. See, I duplicated the GUI add color and unchange, and I'm changing the start with end. Let me check if I got it right. Okay, it's blue, and now I can change it to any color I like. Okay, cool. Finally, we can use those inside the uniforms at start. So that we get the same value. So I'm going to use this one here and this one here. We get the same result because it was the exact same value. See, it was red and blue, and those were red and blue. We did that so that we don't have to change it at different places. If we want to change the color, we just need to change this one. But there is a small problem with the value. If you try some other values, like let's say we are going to go for some kind of blue to, let's say, orange, like this. As you can see, we get some yellow. We're not supposed to get yellow. It's supposed to be clumped to orange. And this provoke like this kind of, you can see the edges like that, but we want like full, like orange on the edges. So this is wrong. The problem is with the fragment. The problem is that the strength can go above 1 and below 0. So the value, the colors get extrapolated even further. And we can fix that. We can fix that by simply adding a clamp. We can use the clamp. So clamp the value, let's say from 0 to 1. So it's over commented, but it's better to have too much comments. And we can do strength equal clamp. And the three parameters of a clamp is the initial value, the bottom limit, and the top limit. And by doing that, we are making sure the strength cannot go below 0, cannot go above 1, and we will get really like a mix from this color to this color, and it won't go further. Like the orange here won't go into the yellows. So it's just an example. You can test with other colors, but that's the idea. Like if you change this one to, see, some kind of purple like that, we can see the pattern here. We are not supposed to see the pattern here. So let's go. We can save this one like that. We get the same result when it comes to red and blue, but if we test again those colors we just tried before, so it's blue and orange, as you can see, it stays orange and it doesn't get extrapolated into wrong colors. And it's better. For us, it's just black and white, and it was working fine with black and white, like that. But for you, if you're using like special colors like orange, stuff like that, you better add the clamp. Okay, I think we are almost set. What we need to do now is choose the right color, so it's up to you. For me, it's going to be black at the center, so at the start, and white on the side. So it's this value here. But for you, it might be different. I don't know, maybe you have some pink. It's going to be something like that. I don't know. You just test, get some values. By the way, you can like add more tweaks, stuff like that. We didn't add too much tweaks because this exercise is already pretty long, but you can add anything you want. And it's looking just fine. I think we are set now. Yeah, I'm going to change those. So for me, the middle one is black and this one is going to be white. Let me check. Yeah, and I get the same result as before. But you can tweak to get something else. All right. It's the end. We did finish those 4 big lessons. I hope it was really interesting. You can go further as always. You can add more tweaks. It's what I told you right before. You can add more features. Like I wanted to add much more features, but you can add a campfire. You can add a wind. You can add anything you want. You can add like particles going in and out of the portal. Add more features. You can add trees. You can add more objects. Obviously, you can change the background because it's kind of boring, but it was not the main focus of the lesson, but you can do like a much better background. And obviously you can create a brand new scene, and I would be so happy to see like completely different new scene. I don't know, create your room, create your garden, create your living room, anything you want using the baking. Like you start from the beginning, you create this Blender model, you optimize, UV unwrap, export, import in 3GS, add details, and I would be glad to see the result all you can create. And obviously, as always, don't forget to share the result. You can share it on the Discord server, on Twitter, mention me, use the 3GS journey hashtag, and I would be glad to see the result. All right, cool.